Welcome back. So the first question is, a solid sphere rolls down two different inclined planes of the same heights but different angles of inclination. Will it reach the bottom of the same speed in each case? Let the height of the plane is h and mass of the sphere is m. Let the velocity at the bottom point of incline be v. So the total energy is given by capital T equals half mv square plus half I omega square. For solid sphere, moment of inertia is I equals 2 by 5 m square. So half mv square plus half 2 by 5 m square into omega square is mgh. Put v equals omega r and solve the above equation. So we obtain half v square plus 1 by 5 v square equals gh. So we get the value of v from this particular equation as root 10 by 7 gh. Thus the sphere will reach the bottom at the same speed since it does not depend upon the angle of inclination. The next question is, will it take longer to roll down the plane than the other? Let us assume the angle of inclination to be theta 1 and theta 2, where theta 2 is greater than theta 1, and the acceleration of the sphere will be g sine theta 1 and g sine theta 2 respectively. Thus, a2 is greater than a1 as sine theta 2 is greater than sine theta 1. Since their accelerations are different, so the time taken to roll down the inclined plane will be different in both the cases. The next question is, if so, which one and why? The equation of motion gives v equals u plus at. So t is proportional to 1 by a. Since we know that a2 is greater than a1, so t2 is less than t1. Hence, the inclined plane having the smaller angle of inclination will take more time.